In geometry, we spend a lot of time talking about logical thinking. We want to use logical thinking to draw conclusions and prove statements true that will be a bedrock or a foundation for coming up with other true statements or proving other things to be true. So what we want to use as an objective is that we can use deductive thinking to draw conclusions. Now we usually start with talking about some of the vocabulary that we use in geometry. Let's talk about the different type of reasoning we have. We use inductive reasoning by using patterns and observations in order to make conjectures and make predictions. Now, this is used often very frequently in order to come up with a statement that will prove logically true. But as an example, for instance, I might say, because it was cold outside last winter, when I went outside and observed, I noticed that there weren't a lot of cars on the road when it got very cold. I might make a conjecture that cars don't run when it gets cold. Now, conjectures aren't always true. Cars can run when it gets cold. It might be that people were just staying inside and staying warm. So the inductive reasoning leads us to make a statement, but oftentimes we have to then prove that statement true or not. So that's when deductive reasoning comes in. Deductive reasoning is when we're using rules or facts or statements that are true to prove other statements true. So as an example, this is usually where we use in geometry to prove things like theorems. We might use definitions, we might use postulates or axioms that are things that are assumed to be true. Once we have this bedrock of things we can use, we use those to prove other things true by using logical thinking. So let's look at a couple statements here. If I had the statement, if the weather is cold, then if the weather is cold, then I am cold, okay? In this is called the hypothesis, the part that comes after the if. This part, the weather is cold, is our hypothesis. The conclusion I draw is that I am cold. So how I would write that is, weather is cold leads to me saying that I am cold. Okay? Now, in this next one, I wear a coat if I am cold. The hypothesis comes after the if in this statement, so it's not at the beginning of our statement here. Instead, this conditional statement has the hypothesis after the if later on. The conclusion is at the beginning. I conclude that I'm going to wear a coat if I am cold. And so if I'm cold, that leads to me wearing a coat. And then lastly, if I wear a coat, so this is the hypothesis here, we start with saying if I start with wearing a coat, then the conclusion is I will wear a hat. Okay, so I conclude with that. Now notice that this logical thinking walks us through things that are connected. If I took out this middle statement would leave a gap between weather is cold and wearing a hat. But because this is all connected with hypothesis leading to conclusion, that becoming the hypothesis leading to another conclusion, then we can say if the weather is cold, you can either conclude that I am cold, that's right, comes right after it, or you can conclude that I'm going to be wearing a coat. Or lastly, you can conclude the very last statement that I'm going to wear a hat. So if I start with the weather is cold, I can conclude I'm going to wear a hat according to these statements, these conditional statements. So that's what logical thinking is that it has all of the steps filled in so that things lead to each other and we can draw conclusions. Let's do that with a mathematical statement. This algebraic statement here, if 3 plus 7x equals 10 times the quantity x plus 6, then I can conclude that x equals negative 19. I want to prove that's true logically through steps. That if I start with this, I can conclude that. So what we say is that the hypothesis here, the part after the if, we say is given to us. That's the part that we're starting out saying that this is true. 3 plus 7x equals 10 times x plus 6. That's given to us as true. Let's say that we want to prove then that x equals negative 19. So I should never use this statement in the proof. It is the ending conclusion that I want to come to at the end. So nowhere in the middle of the proof do I want to use that x equals negative 19. I want to see if it's something that I can produce at the very end logically. So the first statement I'm going to start with is just the given in writing my two-column proof under the statements. So 3 plus 7x equals 10 times x plus 6. That's my given statement. It's the hypothesis. My second statement, I'm going to go ahead and distribute through here. Now, what we do is in a logical sequence of a proof is we want to give a reason for why the step is true. So we're matching, numbering these over here to match step 2. I want to match it with a reason to. Just as I said, I use the distributive property. That's a property that we know in algebra is true. So since we're using a fact that's true, we can use it as our reason. So the distributive property is my reason there. Now, next step, when I want to solve this, I'm going to subtract 7x from both sides. So I get 3 equal to 3x plus 60, and that's because we know that we have a subtraction property of equality. So I'm going to put that as subtraction property of equality with a little bit of abbreviation. The next step is I'm going to bring the 60 over here. So if I go ahead and subtract 60, I get negative 57 equals 3x. And again, it's the same reason, and I'll abbreviate even further. I'll call that SPE for subtraction property of equality. And lastly, just before, actually my second to last step, is that I'm going to state that by dividing by negative 3, I get negative 19 equals x. Okay, and that's by division property of equality. So I'll abbreviate that as well. Then our very last statement here, because we want to prove x equals negative 19 and we've got negative 19 equal to x, let's have them swap sides. Let's have x equal to negative 19. And the reason why we can say that is our symmetric property. Okay, so we have a symmetric property of equality that can tell us that they can swap sides. So logical thinking is based on this deductive reasoning where we might have a conjecture. We believe this to be true. Deductively thinking, we can use things we know are true, facts that are proven, theorems that have been proven, definitions, and we'll use those as reasons to come up with our final statement to show that given this statement, if this is our hypothesis, then our conclusion is true by logical thinking.